Hey again, everybody. Today I'm going to show you my resin printer time-lapse controller. So I have an Elegoo Mars, just got it about a month ago, Mars Ultra 3 4K resin printer, and I wanted to do some time-lapse videos of some of my prints. So I decided to, before I actually did what I'm going to show you here, I actually decided to embark down a path using an ESP32 cam, and I'll link that down below so you can see details about that build. It worked quite well. Basically, it built an AVI file on the fly, snapping photos every time a layer changed on the printer, but I wasn't very impressed with the overall quality, so I decided to sort of go down this pathway. GoPros are much higher quality resolution and more flexible in the settings and easier to actually, use these things themselves. But obviously, I needed a way to trigger taking photos. So for those that don't know, GoPro has a built-in time-lapse function, but it's based on timers, right? And that doesn't work as well with printers, 3D or resin printers, because what you're trying to do is capture sort of a motion move of the printer building the print, and you can only really do that when you catch it on layer changes. With 3D printers, FDM, standard 3D printers, that's done in code, whereas in a resin printer, it's actually much easier. Really, every time a layer is going to be cured in a resin printer, the actual UV light comes on inside the printer, and you can, quote unquote, watch that UV light, and that's what I'm going to show you here with a photoresistor and this guy doing that. So essentially what you see here is this is an M5 Stick C Plus by M5 Stack, and what this guy does is basically it's wirelessly connecting to the GoPro, establishes a connection to that over Wi-Fi. The Wi-Fi is actually not your home Wi-Fi, it's actually local. The GoPro actually broadcasts as a Wi-Fi access point, I believe, and this connects to that. Once connected, you'll see that it's ready, so to say, and there's a couple options here for me to monitor the print. So the printers are basically the setup is ready to go. Now, if you can envision this being hooked up, this guy's sitting watching the print bed, and then this can be anywhere else nearby. This here, I've just wired it directly so I can demonstrate this, but essentially where this I've run this into the back of the printer inside in a non-obtrusive way. It doesn't actually wire to any of the main board and interfere with any electronics whatsoever. It's completely isolated for that. It's just got a bracket that points it in the direction of where the UV light shines at the bottom of the printer. And at least in this one, and I think in most other resin printers, that's a really easy thing to get at. It's not, you don't got to take all kinds of stuff apart or mess with electronics. There's lots of space in there. So I literally printed a clamp that slides onto a piece of plastic, and the sensor just looks over the edge, the light values. The change in light triggers a photo. So essentially what this is doing now is in wait mode. Normally what I would do is I would actually just click the button here. There's actually 3 buttons on this guy, 1, 2, 3. One I've got set up to actually just stop communications with the camera, and I'll tell you a bit more about that in a minute. This guy just starts it. So essentially, generally speaking, the printer starts off dark. You start it, you'll see that what it does is it actually tells the camera to go into photo mode in case it's actually in video mode or time-lapse mode. So it ensures it's in photo mode, identifies that record is on, shows you the number of frames that it's taken. I actually just accidentally took 2 frames because my finger wasn't on the sensor. And then obviously the status shows recording started. So essentially, now envision that printer doing its layer printing. So, the light comes on, goes off, printer raises the bed, lowers the bed, raises the print, lowers the print. Another light comes on to cure, and so on. It's also got code built in to ensure that it's not, right now I got light on. The light stays on sometimes for the first 6 layers. It stays on for 35 seconds. I don't want it taking multiple photos. I want it taking one. So it's built into the code to wait for a transition between dark and light to trigger another photo. And as it's doing that, the GoPro is essentially snapping a photo in sequence. So as every layer changes, as every layer is cured, it prints that. Obviously, for the first, I think it's like 100 to 200 layers. You really don't see much because the actual print bed, or the resin bed or boat, whatever you want to call the thing, is about an inch high. So you're looking into really not seeing anything there until the print starts to rise out. So this really only works well with larger prints, that as they rise out of the print, you start to see the structure building over time. So essentially, that's what this guy does. It works quite well. Right now, I'm showing you these things, powered on their own battery power, but most cases my prints are 2 to 4 hours. So both of these, are powered. They're USB-C in both cases. So both of them are powered by either just one of these guys, nice solid power unit, or directly plugged into the wall, like a wall wart. So essentially, that guy will just run. It takes pictures. Once the print really gets going, I think my settings are 2.5 seconds. So every 2.5 seconds, it goes down, rises, takes another photo. I think the last test I did was somewhat about 900 photos, which I have a 64 gigabyte card in there. Each photo is about 3.8 megabytes, so it handled it just fine. In terms of building the time lapse, it doesn't do it in the GoPro. What I use, and it's very simple. I have, I think it's called VSDC Editor, and it has an animation feature where you can, within 5 minutes, basically you go to create an animation object, you import, all the photos into that object, you set how many frames per second, and you build the animation. And then what you do is you actually set the video to speed up, and I did it anywhere between 700 to 1000%. And then when you build that video and output it, you get a nice smooth, and you'll see in my blog, I'll link my blog below. I've got some other videos I've done where it actually, you now see this nice transition of the object coming out of the resin bed over time. So it's kind of a crude method. There's a bit of work there involved in actually doing it. It's not all, built in. It'd be nice if GoPro had an external input of some sort to do this kind of thing, but I imagine that those of us that do this sort of thing are far and few between for feature improvements. But GoPro works great. This is actually a GoPro Hero 7. I understand I'm using the software I'm using. This is an ESP32 Pico inside this M5 Stick C Plus. And I'm using a very good library that I want to give accolades to, called GoPro Control. I've also played around with a number of different libraries, and you'll see my journey in that fun adventure of trying to get connected to this GoPro. Using Bluetooth. I tried to use Bluetooth as well, because ideally I wanted to use my phone with the Blink app on it to control the microcontroller. I didn't necessarily want to really care for a screen that would then control the GoPro, so I could use my phone to monitor the print. Anyway, that didn't work very well, and I would have needed Bluetooth and Wi-Fi, because Blink and this guy would need to connect via my home Wi-Fi, and then this would talk to this over Bluetooth, and it just got too complicated. I also ran into a lot of issues, and I'm hoping my blog post, again, link is below, will help you with this, because I had a lot of trouble getting these two connected over Wi-Fi. I could always get them connected. I tried a number of different libraries that were Wi-Fi based. I could get them connected, but I had an issue where what would happen is it would have a solid connection to the GoPro, but it would immediately disconnect. And only when I completely reset the wireless connection, or the network connections, I think they call it in the preferences here, only when I completely reset that would it work, and it would only work for the first time, and then it would fail. And I couldn't figure out why. I thought it was something to do with this. I thought it was security related between the comms. I spent a whole week trying to figure out what was going on here, and I just couldn't figure it out. And anyway, in the end, I realized that there's a function call called gp.end inside GoPro Control. You'll see that in my code, the sketch. Essentially, you must call whenever you're powering, disconnecting these two, or powering off one of the two. So you don't want to power off, the GoPro alone or this alone without calling it. So I've built in a lot of features and functions into this to make sure gp.end is called. anytime there's a disconnect between the two. The great thing about this guy is it actually comes, it's a tiny little thing, but it actually comes with a built-in, I think it's a 170 milliamp hour battery, which is great because it means that in case I'm USB powering it, you know, when you're doing these kind of things, you just don't think, and you know, I would unplug the power and suddenly it would power down and I'd be messed up. Instead, I now have this. I can do graceful shutdown. I do it by actually pushing and holding this button for 2 seconds, and it will stop the recording, hit, you know, call GP end, and have a graceful disconnect, and then it will gracefully reconnect. I found that, again, after many troubleshootings, I had initially thought that I had to completely reset the wireless connection, which meant I had to reconnect the GoPro to my computer and all this crazy stuff. In the end, I realized that it's an easy reset in case you do screw up. You don't have to redo everything. Basically, I just power down the GoPro, pull the battery roughly for about a minute, and then put it back in, and then repower up the 2 devices, and then it usually reconnects. If it doesn't, just do it a little bit longer, but it will reconnect. I've tested this many times, and it does succeed. Another feature I've got built into this too is, for those of you who have resin printers, is you'll know that at the print's done, you know, obviously the UV light no longer shines, and but you don't really know that. I don't have any triggers to actually tell this to stop recording. The great news is that, you know, when it's in dark mode, it doesn't do anything anyway, it's just sitting there, but obviously everything's powered up and it's still in the linked communications mode. So what I do is I have just a simple timer. I estimate about a 2-minute delay is sufficient. So after 2 minutes of inactivity, of, you know, changing of UV light off and on sequencing, it'll just initiate a stop, basically stop recording, and basically disconnect the 2 devices, so that, you know, in case they lose power or batteries run out, nothing is wrong. You've got the photos stored on the GoPro and you're good to go. So you know, there's lots of more things I could do here, but it does the job. It's somewhat crude. Obviously, this is, again, as I mentioned, just me connecting a photodiode photoresistor to my pigtail here that I put together. Again, schematics are in my blog. You can see how to create this. It's really simple. You know, single sensor and some code, and suddenly you've got, you know, communications between the 2 devices. I'll just initiate stop recording here. So it just tells you recording is stopped, recording is off, and resets the frames. I could actually start again, so I could actually reinitiate a connection. Beeps to let me know that. It starts all over. Nothing changes on the camera in terms of, like, it's still taking photos. It's still taking photos in sequence. It doesn't know that I've started a new quote-unquote recording. It's just taking another photo and incrementing the number of the photo name on the GoPro. So that's useful, because in case something goes wrong mid-print, I could easily just restart things and it'll just keep going with the photos. You might miss a couple layers, but, you know, the big scheme of things, when you've got, you know, upwards of 1,000 to 1,500 frames, it's not going to be noticed. So you're good. Anyway, my blog, again, on my blog, I've posted a link down below this video with a full build log of how to pull this together. You don't have to use this M5 Stick C+. You can use it pretty much, I would suggest an ESP32. It's a bit overkill for processing power, because there's really not a lot of processing needed to get this done. I suspect you can get this working on an ESP8266 as well. Basically, you just need or an Arduino MKR, you know, any Wi-Fi enabled chip. I suspect would be no issue getting this working. You know, with GoPro Control. It's GoPro Control. I've linked it in my blog. It's well documented. It supports I think all the versions of the GoPros. This is a Hero 7, as I mentioned, but there's many other GoPros that it'll support. You may have to do a bit of tweaking here and there of the code, but very nice library, very impressive. Yeah, and I really like this M5 Stick C Plus. It's a very nice little device, and maybe I might just do a review on it as well. It's a nice separate battery powered unit that can do all kinds of things, and you can use that display to help you you know, keep track of things. Anyway, I hope you enjoyed this video. Please, you know, I appreciate the support. Please like and subscribe. It's people like you that help me, drive me to do more of these kind of projects, and hopefully I can save you many hours trying to build something yourself. Thanks. Have a good day.